So welcome to s.mathguru classes. Today we start Cayley-Hamilton theorem, new topics, new portion. So Cayley-Hamilton theorem, the statement is that the Cayley-Hamilton theorem statement is that every square matrix satisfies its characteristic equation. That is, for a square matrix A of order n, determinant A minus lambda I, this is the characteristic equation. This equal to, if we expand, we get this minus 1 to the power n lambda to the power n a1 lambda to the n minus 1 plus a2 lambda to the power n minus 2 dot 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 an. Then the matrix equation lambda equal to putting x, a1 x to the power n minus 1, a2 this one, I, this matrix equation, we it cannot be single term, so it must be with I. Then it is satisfied by A. Putting x equal to A, then we get, in place of x, putting A, this is this one, this, just like this. Just in place of x, we putting A. A satisfies this equation. This matrix equation satisfies by A. This is a Cayley-Hamilton theorem. Every square matrix satisfies its characteristic equation. Suppose A is a square matrix of order 2, suppose order 2, that means 2 by 2 matrix, order 2. If we expand this, we get, suppose we get lambda square minus 3 lambda plus 5. Suppose this one we get 5. So this one we get by A minus lambda I equal to 0. By solving this, we get this one. Then this A satisfies this equation, a square minus 3a plus 5i equal to 0. A satisfies this equation. Again, if we get A is a square matrix of order 3, this is 3 by 3 matrix. Suppose determinant A minus lambda I equal to 0, this is the characteristic equation. If we solving this equation, we get this order 3 means we get cubic equation, lambda cube minus 5 lambda square plus 6 lambda plus 7 we consider, this equal to 0. Then this A satisfies this equation. In place of lambda, if we putting A, then we get this one, 6a plus 7i equal to 0. This is our Cayley-Hamilton theorem. Every square matrix satisfies its characteristic equation. This is the characteristic equation. In place of lambda, if we putting A, we must have right hand side. This is our Cayley-Hamilton theorem. Now let us consider one problem. Now we consider this problem. Find the characteristic equation of the matrix A equal to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and verify that it is satisfied by A, and hence obtain A inverse. So from this we have to find the characteristic equation and we have to verify it satisfied by A, that means Cayley-Hamilton theorem, and hence obtain A inverse. From this we have to find A inverse also. Now solution, the characteristic equation is determinant A minus lambda I equal to 0. So determinant A minus lambda is 2 minus lambda minus 1 1 minus 1 2 minus lambda minus 1 1 minus 1 2 minus lambda, this equal to 0. This equal to 0 we get. So this one, just subtract lambda from diagonals and we expand this one, 2 minus lambda, then this cancel, we get 2 minus lambda square minus 1, this into this minus this into this, then minus this cancel, this into this into this, this is minus 1 into 2 minus lambda, this into this plus 1 plus 1. Then this cancel, this into this 1 minus this into this 2 minus lambda. This equal to 0. Now this implies 2 minus lambda, this is a minus b whole square, a square minus twice ab plus b square minus 1. Minus minus plus, this is minus 2 plus lambda plus 1, 1 minus 2 plus lambda equal to 0. And this 2 minus lambda, lambda square minus 4 lambda, 4 minus 1, 3. This is this and this minus 1 plus lambda, this and this minus 1 plus lambda, this equal to 0. So we get this one. This implies this is multiplying all of this by 2 and by minus lambda. Multiplying by 2, then 2 lambda square minus 8 lambda plus 6. Multiplying by 2 we get this, and multiplying by minus lambda cube minus minus plus 4 lambda square minus 3 lambda. And this is lambda 2 lambda minus 2. 2 lambda minus 2 equal to 0. This implies minus lambda cube plus 6 lambda square minus 8, this minus 1 minus 9 lambda, 6 minus 2, 4. This equal to 0. Multiplying by minus sign, then lambda cube 6 lambda square plus 9 lambda minus 4 equal to 0. So we get lambda cube minus 6 lambda square plus 9 lambda minus 4 equal to 0 by Cayley-Hamilton. This is the characteristic. Find the characteristic equation. This is the characteristic equation we get, and hence verify it is satisfied by A. By Cayley-Hamilton theorem, we have what we have. This is a cube minus 6a square plus 9a minus 4i equal to 0. So by Cayley-Hamilton theorem we get, just putting lambda equal to a, we get right hand side. This is the Cayley-Hamilton theorem. Now we verify this, verify that it is satisfied by A. Now this is our Cayley-Hamilton theorem. So first we find a square. A square equal to a into a. A means 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and this is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. We get this. We multiplying this. That rule is this row multiplying this column, this column, this column. 2 into 2 plus minus 1 into minus 1 plus 1 into 1. This column is finished. Again 2 into minus 1 into 2 plus 1 into minus 1. 1 into minus 1. This column also finished. Again 2 into 1 plus minus 1 into minus 1, 1 into 2. We get this. Similarly, taking this row, multiplying with this column, this column, this column. Minus 1 into 2 plus 2 into minus 1 minus 1 into 1. Minus 1 into minus 1, 2 into 2 minus 1 into minus 1. Minus 1 into 1 plus 2 into minus 1 plus minus 1 into 2. Similarly, we are taking third row, multiplying in this way. 1 into 2 plus minus 1 into minus 1, 2 into 1, 1 into minus 1, minus 1 into 2, 2 into minus 1. And 1 into 1 plus minus 1 into minus 1, 2 into 2. So this implies this is 4, 1, 1, minus 2, minus 2, minus 1, 2 plus 1 plus 2. This is minus 2, minus 2, minus 1, and 1 plus 4 plus 1. This is minus 1, minus 2, minus 2, 2 plus 1 plus 2, minus 1, minus 2, minus 2, and this is 1 plus 1 plus 4. We get this one. So if we adding this, now if we adding this, then this is 6. We get 6 minus 5, 5. And this one minus 5, 6 minus 5. This is 5 minus 5, 6. This one we get a square. A square we get this. Now we have to find a cube. A cube equal to a into a square. A means 2 minus 1, 1, minus 1, 2, minus 1, 1 minus 1, 2, and a square just we get 6 minus 5, 5, minus 5, 6, minus 5, 5 minus 5, 6. We get this one. And in multiplying this, now this will be multiplying this row with this column, this column, this column. 2 into 6 plus minus 1 into minus 5, 1 into 5. This column is finished. Next, 2 into minus 5, this minus 1 into 6, 1 into minus 5. This. Again 2 into 5 plus minus 1 into minus 5 plus 1 into 6. So, we multiplying this row with this column, this column, this column. Similarly, we select second row, again we multiplying in this way. So, it has a technique, no need to see here. Again minus 1 into 6, no need to see this matrix. Just minus 1 into 6, write this 6, right hand side 6. Minus 1 into 6, then 2 into minus 5, then minus 1 into 5. We can easily solve this. Minus 1 into 5, no need to see this matrix. Directly write this minus 1 into right side, 2 into right side, minus 1 into 5. Again minus 1 into minus 5, 2 into 6, minus 1 into minus 5, minus 1 into 5 plus 2 into minus 5 plus minus 1 into 6. We get this. And third row, 1 into 6, minus 1 into minus 5, 2 into 5. First column finish, 1 into minus 5, minus 1 into 6, 2 into minus 5. Again 1 into 5 plus minus 1 into minus 5 plus 2 into 6. We get this. So this will be 12 plus 5 plus 5. This is minus 10 minus 6 minus 5, 10 plus 5 plus 6. This is minus 6 minus 10 minus 5 and 5 plus 12 plus 5, and this is minus 5 minus 10 minus 6, 6 plus 5 plus 10 minus 5 minus 6 minus 10. This is 5 plus 5 plus 12. We get this. So this will be 22. This is 11 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22. We get this. 22 minus 21, 21 minus 21, 22 minus 21. This. We get this is our a cube. A cube equal to this. Now I want to write this a cube is here. Rewriting this a cube. A cube is 22 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22. This is a cube. We putting the values in left hand side of equation 1. So we taking left hand side. In left hand side, a cube minus 6a square plus 9a minus 4i. These are left hand side. Now I putting the values of a cube, a square, a and I. A cube is we get 22 minus 21, 21, and this is minus 21, 22 minus 21, 21 minus 21, 22, and 6a square. A square means 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6, 9a. A is 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2, and minus 4i. I is 1 0 0 0 1 0 0 0 1. We get this, and this will be 22 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22, and this is 36. This is minus 30 plus 30 minus 30, 36 minus 30, 30 minus 30, this is 36, and multiplying by 9, this is 18 minus 9, 9 minus 9, 18 minus 9, 9 minus 9, 18, and multiplying by 4, this is 4 0 0 0 4 0 0 0 4. We get this. And if we adding and subtracting 22 minus 36 plus 18 minus 4. Minus 4 and minus 36 we get 40, and 18 and 22 is 40. So this will be 0. Ultimately, if we adding all of these and subtracting, then answer will be 0. So we get right hand side. So our requirement this equal to 0. So we get this, hence verified. This is the verification. Hence verified. Our problem given, verify that it is satisfied by A. In characteristic equation we putting A and putting the values of A square, A cube, then we get right hand side. So it satisfied this. Now next part is given, hence obtain A inverse. We have to find A inverse. What we get, therefore A cube minus 6A square plus 9I minus 4I equal to 0. Next our requirement A inverse. So multiplying both sides by A inverse, then we get if we multiplying both sides by A inverse, then we get this. This and this we get A square. This and this we get A, and this and this we get 9i, and this we get 4 inverse A inverse equal 0. So 4 A inverse taking on right hand side, 4 A inverse equal to A square minus 6A plus 9i. This implies 4A inverse equal to A square. A square, you know this value. Putting the value 6 minus 5, 5, minus 5, 6, minus 5, 5 minus 5, 6, minus 6A. A means 2, minus 1, 1, minus 1, 2, minus 1, 1 minus 1, 2, plus 9i. I means 1, 0, 0, 0, 1, 0, 0, 0, 1. We get this. And this implies 4A inverse equal to 6 minus 5, 5, minus 5, 6, minus 5, 5 minus 5, 6, and multiplying all of these by 6, 12 minus 6, 6 minus 6, 12 minus 6, 6 minus 6, 12, and multiplying by 9, this is 9, 0, 0, 0, 9, 0, 0, 0, 9. We get this. So this implies 4A inverse equal to, and this adding 6 minus 12, 6 minus 12 plus 9. We get this 6 minus 12 plus 9, minus 5, minus 5, minus minus plus 6, plus 0, and the last element 5, minus 6, minus 6 plus 0. Next, minus 5, minus 5, minus minus plus 6, plus 6 plus 0, and this is 6 minus 12, 6 minus 12 plus 9, and this is minus 5 plus 6, minus minus plus 6 plus 0. This is 5 minus 6, 5 minus 6 plus 0, minus 5 plus 6 plus 0, and the last one 6 minus 12 plus 9, 6, this minus 12 plus 9. So this implies A inverse equal to 1 by 4, this is 15 minus 12, this is 3, this is 1, minus 1, 1, and this is 15, 3, 1, minus 1, 1, 3. So we get this one, 3, 1, minus 1, 1, 3, 1, minus 1, 1, 3. And this is the final answer. So it has 3 parts. First part is characteristic equation, already fine. And second part, Cayley-Hamilton theorem, it's satisfied by A, already we get this equal to 0. And multiplying both sides by A inverse, we get A inverse. This is the last part. So dear students, this types of problem is very important for exam. So if you are enjoying with this problem, please share the video to other friends also. They will get some interest. So thank you for watching the video.